Did you know the angle of a plane's wings can make all the difference in the sky? The secret lies in the dihedral effect. Think of it like the balance on a bicycle. Passenger and cargo planes have a positive dihedral angle, making them super stable, just like your trusty cruiser bike. On the flip side, fighter jets have a negative dihedral angle, boosting maneuverability like a nimble BMX. Other factors that shake things up: wing sweep, vertical center of gravity, and anything altering sideward forces during a side slip. So next time you see a plane, remember, those wing angles are working magic up there.
Exposing the secrets of the skies, from balloons to drones, let's explore the types of aircraft that rule the air. First up, lighter-than-air aircraft. Think hot air balloons and airships. Hot air balloons lift off using heated air, while airships have engines and steering for controlled flight. Tethered aerostats? They stay put, perfect for surveillance and research. Now let's get heavier than air. Aerodynamic lift is the game here. Commercial airliners like the Boeing 747 and Airbus A380 connect cities and the world. Military jets like the F-16 are all about speed and combat. Helicopters like the Bell 206 can take off and land vertically, making them rescue champs. And let's not forget cargo planes like the massive Antonov An-225, hauling goods globally. Lastly, drones. These unmanned aerial vehicles range from hobbyist toys to advanced military machines. So next time you look up, remember there's a whole fleet of different aircraft up there.
Why do airplanes fly so high? Let's dive into the science behind it. First up, weight. This is gravity pulling the plane down. It depends on the plane's mass, fuel, and cargo. Now, thrust is the push that drives the plane forward, fighting against drag, which is like the air pushing back. Then, there's lift, the magical force that pulls the plane up into the sky. Lift and weight balance each other out, just like thrust and drag do. Here's the cool part: these forces are constantly at play, and the pilot needs to adjust the controls to keep everything in balance. So next time you see a plane soaring overhead, remember, it's a dance of weight, thrust, lift, and drag. And that's the science behind flight.
You need to watch this if you struggle with understanding aircraft controls. Ready to soar? Let's dive in. Imagine the aircraft elevator as a magic wand for the plane's nose. Located at the tail, elevators control the pitch, moving the nose up or down. When the elevator moves up, the nose rises, making the plane climb. When it moves down, the nose lowers and the plane descends. But it's not just about up and down. Changing the pitch alters the angle of attack, which tweaks lift and drag. This affects speed, fuel efficiency, and altitude. Elevators also keep the flight stable, balancing lift and weight. And how do pilots control this magic? With the control column, push forward to lower the nose, pull back to raise it. Simple, right? Understanding elevators means understanding flight. Keep soaring high, folks.
Why do 85% of engineers swear by complex numbers in aerodynamics? It's all about the Cauchy-Riemann equations. All right, engineers. Imagine you're designing a plane. You need to understand how air flows around it, right? Enter the Cauchy-Riemann equations. These bad boys help us analyze fluid flow using complex numbers. They ensure the flow is smooth and consistent, essential for stable flight. Think of them as the secret sauce that blends real and imaginary parts of a function. These equations make sure there's no sudden turbulence, keeping your designs efficient and safe. So next time you hear Cauchy-Riemann, remember, it's not just math, it's the backbone of aerodynamics. Fly high with those equations, engineers.
Why do supersonic jets suddenly slow down mid-flight? Meet the normal shockwave. Let's break it down. Imagine you're driving a car at high speed and hit a speed bump. Boom, you slow down instantly. That's what happens when a supersonic flow meets a normal shockwave. So what's a normal shockwave? It's a shockwave perpendicular to the supersonic flow, causing an abrupt change in flow properties. Think of it as an invisible wall that slows down the flow from supersonic to subsonic. Here are the key features. First, Mach number drops from over 1 to below 1. pressure, temperature and density all spike up, and energy, it's not lost but converted internally, raising entropy. In short, a normal shockwave is nature's way of saying, "Slow down, buddy, want to know more? Hit that subscribe button." This is why you need to know about ailerons. They're the secret to turning planes with ease. Ailerons are tiny wings on the back edge of an aircraft's main wings. When a pilot moves the control stick or wheel to the right aileron goes up and the left aileron goes down. This changes the shape of the wing, reducing lift on the right side and increasing it on the left. The result, the plane rolls to the right. Ailerons are essential because they allow the plane to turn by rolling it sideways. Without them, pilots would struggle to navigate the skies. Fun fact, ailerons were first introduced in 1908 and became common on planes by 1915. So, next time you see a plane turning gracefully, you'll know the magic behind it. Ailerons.
Ready to debunk a common aviation myth? Let's dive in. So, you've probably heard about buoyancy, the force that keeps ships afloat and hot air balloons soaring. But guess what? When it comes to airplanes, buoyancy takes a back seat. For aircraft, the real hero is lift. Lift is generated by the wings when air flows over and under them, and it's all thanks to Bernoulli's principle and Newton's third law. Bernoulli's principle? It says that faster air over the curved top of the wing creates lower pressure, sucking the wing and the plane upward. Newton's third law? For every action, there's an equal and opposite reaction. The wings push air down and the plane goes up. So, next time someone tells you airplanes float like balloons, you can set them straight. It's all about that lift. Stay curious, aviation enthusiasts.
I will show you how to get the best understanding of airfoil evolution of your life, from early experiments to modern marvels. In the 19th century, George Cayley had a vision. He realized curved surfaces could generate lift when air flows over them. Fast forward to the Wright brothers, who fine-tuned this concept with their homemade wind tunnel, testing countless airfoil designs to perfect lift and control. Their breakthrough, a curved shape that manipulated airflow just right. Then came Ludwig Prandtl, the mastermind who gave us the math behind it all. His theories explained how airfoil shapes alter airflow to create lift, revolutionizing aircraft design. Thanks to these pioneers, we've gone from simple gliders to sophisticated jets. So next time you see a plane, you'll know every curve has a story. Fly high, science students. Have you ever wondered why most airplanes are painted white? Well, it's not just a matter of aesthetics. There are some pretty surprising reasons behind it. First off, let's talk about practicality. White paint reflects sunlight, which helps keep the interior of the plane cooler, especially when it's grounded and the engines are off. This means less heat damage and a more comfortable temperature for passengers boarding and disembarking. Plus, white paint protects the plane from harmful UV radiation, preserving those composite materials that modern aircraft are made from. Now let's get into the economic benefits. White paint is cost-effective and works well with lightweight materials used in aircraft design. It's also less prone to fading, which means airlines save money on repainting. Imagine the hassle of constantly having to repaint an entire fleet. When it comes to safety, white paint has its perks too. It makes it easier to spot cracks, corrosion, and other wear and tear on the aircraft, allowing for quicker and more efficient maintenance. And let's not forget visibility. White paint provides a clean base for displaying those colorful airline logos we all recognize. So, the next time you look up and see a white airplane soaring through the sky, you'll know there's a lot more to that color choice than meets the eye. Thanks for watching. If you found this surprising and interesting, don't forget to like and subscribe for more. Stay curious.